Which ceramic materials can be selected for low or high thermal conductivity, and what are the values? When we think about ceramics, our first instinct might be to assume they're always excellent thermal insulators. However, the reality is that engineering ceramics come with a wide range of thermal conductivities, with the lowest and highest values varying by 200-fold. It's important to note that electrical insulation and thermal insulation are independent of each other. So, you can choose an electrical insulator that's also an excellent thermal conductor, which is very useful for electronic substrates that need to extract the heat from a device, such as a mobile phone or laptop. And, interestingly, the reverse is possible too, though this is often achieved by coating metals with a good ceramic insulator. Now, let's dive into some of the ceramics that are commonly chosen for thermal insulation. We have alumina, the zirconia family of materials, various silicates like cordierite, steatite and porcelain, and then there are the machinable ceramics such as Maycor, and really high thermal conductivity ceramics such as aluminium nitride and beryllium oxide, known as beryllia. We measure thermal conductivity in units of watts per meter Kelvin. And Maycor, for instance, has a thermal conductivity of just 1.5. Silicate ceramics used for electrical insulation typically fall in the range of 2 to 4, whilst zirconia-based ceramics hover around 3. Alumina toughened zirconia goes up a bit to approximately 6 watts per meter per Kelvin. And when you look at the alumina-based ceramics, they're in a different league with values ranging from 25 to 40, whilst Schapel, another machinable ceramic, undergoes a significant leak to about 90 watts per meter per Kelvin. With aluminium nitride, we get values of 170 to 200, whilst beryllia gives us 300 watts per meter per Kelvin, as good as copper. Beryllia, however, we must be aware, is toxic. It only gets used by the military for substrates. The reasons for these different thermal conductivity values are well documented and can be easily researched if needed. Essentially, it comes down to how much the thermal vibrations, known as phonons, are disrupted by the crystal or microstructure. Now, when it comes to thermal barrier materials, we have alternatives like plastics, glasses, some metals such as stainless steel, thermal barrier coatings and fibre composite based materials. The choice amongst these depends on the specific application and design requirements. Factors like temperature range, which may rule out polymers and metals, the surrounding atmosphere, which might necessitate particular ceramics, and whether there will be mechanical loading or rapid temperature changes, amongst other considerations, all come into play. Which applications may require thermal insulation properties? You can discover more about materials guidance and find application examples on Precision Ceramics website's materials pages. Some typical applications include high power electronics, cryogenic systems, high temperature processing, furnaces, jet engines and space applications such as heat insulation and electronic substrates in satellites, among many others. The website offers comprehensive insights into how these materials play crucial roles in various industries and technologies. Which applications may require thermal conduction properties? There are many situations where extremely high thermal conductivity is essential for effective heat dissipation. A prime example of this is in electronic devices such as mobile phones or games consoles, where the components generate significant amounts of heat. In such cases, the ability of the substrate material to efficiently transfer that heat away from the components is paramount to prevent overheating and hence ensure optimal performance and reliability. High thermal conductivity materials become indispensable for managing this heat and maintaining the electronic system's functionality.